Okay, so thanks for logging in and getting started. Right now you should be able to see screen 1, this warm-up screen, where you're just going to draw a distance time graph and press play, see what happens. This is the mechanics of the lesson. So just kind of interact with it. We'll talk about what's going on here in just a second. So I'm going to invite you back to the Teams call. You should be looking at my shared screen right now. And I'm just going to show some of the fun warm-up drawings. I'm so excited to share your work with you all. Notice, what do you see that's the same? What do you see that's different about what's in front of us here?
Some of the lines are squiggly and some are very straight.
Okay, cool. So this one in particular is very straight, and then these ones are a little bit squiggly. Anything else that y'all observe?
Some of the lines are more flat and some are more steep.
Awesome. All right, so these are things that we're going to talk about later today. Flatness versus steepness, what they do. Hopefully you had a chance to click play, so I'm just going to go into this one and hit play. What happens when we hit play? What's happening on the screen in front of us?
The turtle is moving.
Awesome. So the turtle is moving, right? I'm going to click this steeper one. Think about that last video versus this one. What's happening here?
Turtle is moving fast.
Interesting. All right. So these are things that we're going to talk about today, right? Like something about this sketch and this turtle is related, right? And then just the last one, it was shallow and straight. Do you think that the straight line has any effect on what the turtle will do?
My adult brain says that the speed is going to stay.
Okay. That's your adult brain. Let's check it out. I mean, but it's slow, right? It's slow, but this turtle is always making some progress, right? So we're going to take a look a bit more at turtles today. That's going to be the context of our lesson. And what I'm going to invite you all to do is go back to your Desmos screen, and I'm going to open up slides 2 and 3. And I just want you, based on your quick sketches, make a prediction here, right? I just want to know what you think Luca's graph is going to do for the turtle. And then screen 3 is going to be a reveal. So take a couple minutes, work through screens 2 and 3, please.
When you click, and tell me if you're going to talk about this later. So I know how to pause. I did not know how to open up just like the next 2.
Yeah, so that's pacing control, and I will show you explicitly how to do that. I can answer that now, but it just involves clicking this button, pace. I'll stop pacing. So right now you would have access to all slides. Mm-hmm. By clicking pacing, I'll get a prompt of where I want to start. Okay. I started you on screen 1 and screen 1 only, and then I used this. This is like a shortcut, so I don't have to keep doing that interaction. I moved you all to the right, and then I added one screen so that you have access to these 2. Yep. So that was
awesome. Okay.
Yeah, so now I can focus. So I really just want you all to focus on screens 2 and 3 for right now. It's a prediction and then a reveal. Okay, pause coming, about 5 seconds here. Whether you've gotten to the reveal or not, that's okay. I'm so excited about these predictions. I want to share them with us. So pause coming here, 3, 2, 1. Okay, your Desmos screen should be paused. I'm going to invite you back into the Teams call. I'd love to take a look at some of your predictions that you all made. So please join me back in the Teams call. Okay, can you all see my screen?
Yes.
Perfect, thank you. So we've got 3 different predictions here, and we're not going to belabor this, but I just want you to see how similar, right, we've thought. So based off of this graph, we said the turtle kept moving away from the water. And my question here is this particularly clear about what happens? And how do I know the turtle is moving away from the water? We don't need to answer that right now. I just kind of want to plant that seed in your mind. And then looking at these 2 students, right? Move slow, stop for 2 seconds, move fast, and then stop again. 2 seconds. That's fascinating to me, how the student was able to pick up 2 seconds. And this one, the turtle starts off moving and then stops. He then starts moving again more quickly and then stops. So I love the ideas that you all are picking up on of movement and, like we saw in the warm-up, that speed, right? Somehow related to how steep this is. And then I love picking in on the idea of stopping for 2 seconds. So let's take a look at, the reveal, right? We'll just look at it together here, hopefully on screen 3. But if not, let's hit play. So we're going up, stopping for 2 seconds, and then we're going much faster. And ultimately we are stopping. And at this point we are across the sand in the grass. Wonderful. So great job with your predictions. I appreciate that. Now let's see if we can kind of pick up on some of those key features here. So I'm going to move you all to screen 4. I'm going to open it up and I'm going to ask you to try to interpret this graph based on those key features that we saw before, right? The stopping for 2 seconds, the speed. I'm wondering if you all can read this graph to try to answer what's the turtle's distance at 8 seconds and when is the turtle's distance from the water 4 feet. So just a second on slide 4 there. I will unpause and invite you to continue that way. I'm gonna bring you back to the Teams call here. Appreciate your patience as we toggle back and forth. So we've all come to consensus. We see 10 feet and 5 seconds. And what I really want to highlight is one of our classmates here, which for the purpose of this demonstration is me, grade level student. Like a pro tip, right? I did the activity myself and I'm going to kind of break the lesson here. I did it myself so that one, I would know what students could do, but I want to anticipate and think like a student. Sometimes I want to think like a student that doesn't quite get it. And sometimes I want to put the thing that I want my students to do. So I'm about to show you the thing that I want students to do. And I've done that as a teacher, but I'm pawning it off like it's somebody in the class if I use anonymize, right? So all of a sudden anonymize, yeah, there's only 3 of us and I've given it away that it's me. But in an actual class where you've got 20 something students, they'll have no idea it was you. And I want to highlight this thinking, this type of thinking, since we all arrived at the answer 10 feet and 5 seconds, but I want to show off that you could use Sketch to make your thinking visible. So here's what I'm inviting you to do on this screen here, right? We've all reached consensus of 10 feet and 5 seconds, but I'm going to offer some praise to this student, which happens to be me, but they don't know that. And if it's a student in your class that does it, highlight their work instead. But I'm going to highlight here, what I love is that we got to 10 feet and 5 seconds, but this student took a moment here to just sketch. And I can see that at 5 seconds, they know, sorry, to answer the question at 8 seconds. So at 8 seconds, we've gone up and over to read this graph. We are 10 feet from the water. And then the other question, when is the turtle's distance from the water 4 feet? I can see that this student went up to 4 feet, came over to the graph and figured out that that is at 5 seconds. So just that one little move, using the sketch, using the graph to show your thinking. I love that. I appreciate that. We can all get 10 feet, 5 seconds, but maybe think about how you can utilize what you have in front of you to try to make your thinking visible to the rest of us. So thank you for that. Okay, we're pretty good with these simple graphs. I'm going to invite you to a challenge screen here. So I'm going to unpause, and on screen 5, I want you guys to take a look and think about what this turtle might be doing. So I'm going to unpause. You are on screen 5 now. If you go back into the Desmos activity and think about Arnav's graph, what is his turtle doing? I'd love to see the predictions you all make. I'm loving the predictions I'm seeing. I'm so excited to share your predictions with each other. Take another 30 seconds or so here, kind of formulate your thoughts, and then we'll begin talking about it. Okay, another 5 seconds here for your final revision, and then we're chatting. So give me one moment here. These are incredible. I'm so excited here. All right, pause coming in 3, 2, 1. The pause is real. Okay, please come back to our Teams call. And I'm so excited about these. Arnav Circle Journey. Can you all see my screen? Please give me a verbal yes or a head nod. Okay, I see it. All right. This is a tougher graph, right? We've got more going on here, this circle. So let's take a look at these predictions, some shorter than others, but they all kind of hit on the same thing. So the turtle started walking away from the water, then he went in a circle, then he kept walking away from the water. So I kind of see what we're talking about here. Walking away, going in a circle, keeps walking away. All right, that's going to be our first choice. Second choice, started away from the water, walked in a curve, and then walked towards the grass. Okay, I remember the grass. So do these two stories seem similar to you all? You can give me a head nod or a thumbs up in the chat there. Okay, so very similar stories. Okay. Then this last one, a bit longer. Let's read it. The turtle starts off out of the water. Okay, interesting. So we're already like a head start on the beach somewhere. Then the turtle either continues moving forward or starts to walk back. So we think that the turtle has to choose a path. Okay. If the turtle continues forward at 6 seconds, he starts to move backwards. So if I go forward like this, then I'll start coming back. I see what's going on there. But if the turtle started walking backward, then at 6 seconds, the turtle will start to go forward. And then I think the student probably just ran out of time. Presumably we'd kind of pick up like everybody else. Okay, are y'all ready to see it?
Yes.
Yes, let's see. First, we're going to commit to a vote here. Do we think that the turtle is going to walk in a full circle, or do we think it's going to choose one or the other? So just in the chat here, if you can give me like a hand raise, who thinks that we're going to go a full circle? Hand raise. Nobody. Who thinks that we're going to have to choose a direction? Hand raise, please. Okay. Caitlin, thanks for committing. I appreciate that. All right, let's take a look. Let's find out. And I'm just going to ask you to stay on my screen. We're going to take a look. So, are we ready?
Yes.
So we were out of the water. We're walking forward. And right here, whoa!
Whoa.
Interesting.
Now there's two turtles.
What just happened?
Huh, that's awesome.
2 turtles. All right, so I'm going to ask you all, let's have a talk about it. What was surprising? What was, I heard a whoa. Please unmute, chat, comments, and we'll just try to take turns here.
I was not expecting 2 turtles.
Weren't expecting 2 turtles. All right, interesting. Is it 2 turtles? Like, I'm going to challenge you there a little bit and say, is it 2 turtles? Or is it 1 turtle? And how do you know?
I think it's 1 turtle and you're showing both the possibilities at the same time.
Okay, so right here, 1 turtle, and then, so I'm going to control this, right?
Yeah.
Right here, it could have, so Caitlin, I'll give away that it was your script there. So you kind of ran through both scenarios. And in fact, Caitlin, you were like spot on, right? You said if it goes forward at the 6 second mark, then it will go backwards. And if it goes backwards, it will go forward. We just did both, right? So Sunita,
Yeah.
maybe you kind of like that we're showing both possibilities there.
Yeah.
Caitlin, you were going to say something else before I started talking.
No, I was actually going to say that instead of it just being like one of the options, that visual is showing like the entirety of the graph, not just one direction or the other.
When you say this visual, you mean this little video?
Yeah.
Gotcha. This little video clip or whatever. Yeah. So like, 'cause they're both visuals, right?
Yeah. Although the points on the graph showed the same thing, but I think the turtles from like if I were a student, the turtles would show it in a way that would resonate with me a little bit more. But I'm sure there are some kids where the dots on the the points on the graph are gonna.
Yeah. And so now we're kind of blending our hats here between are we students, are we teachers, and I'm fine to go back and forth. But that's what we hope, right? We hope that students start to see there are 2 dots right here. And to Sunaina's point from earlier, Sunaina, I'm going to ask you, commit. Do you think it's 2 turtles or do you think it's 1 turtle? I mean, like, what would be more plausible in real life?
1 turtle and just both the scenarios at the same time.
Okay, I'm going to throw this one out there, right? What if it's 2 turtles the whole time and one is just riding on the turtle's back and right here it hops off? Like, could that happen in real life?
Yes.
Yes.
It could. Is that probably what's happening here? Probably not. I mean, at this moment, like, I think that's probably unlikely, right? But that would at least explain this in the real world. If it's 1 turtle, could this ever happen in real life? Do turtles spontaneously split?
No.
Right. So what we're going to try to focus on today is really the beginnings of something called functions. Okay, and functions is the math that we can do. So what we can represent with a graph, and we're going to try to figure out, could it be real life, a function, or is it maybe theoretical? Right? Like, this can't happen in real life that a turtle splits, but we can represent both ideas at once, or we could have this idea of 2 turtles at the same time, and we can use things about the graph to figure out at least the direction the turtle is moving, right? Is the turtle moving forward or backward? And how might we know based on looking on this graph without needing a video? Okay, so what I'm going to ask you all to do is hop back into your Desmos activity, but I'm going to keep you on the screen for just 1 second. The next couple screens is kind of a challenge. You're going to see a turtle try to cross the sand with snakes. You'll notice that it pauses on its journey. It backs up a little bit, and then it moves forward to get safely all the way across the sand, right? Turtles have to do this in real life. We're going to try to draw that. So your challenge is on screen 7 to watch that video, and then on screen 8, you're going to be able to sketch how you think this turtle might get across the sand smoothly, and you will find out if it does or doesn't make it by getting a little visual here. I didn't make it, right? I'm getting eaten up by the snakes, but you can also see this ghost. So if you want to try that ghost, you'll notice as I move on the graph, I have a little bar. It's the turtle's nose is what the graph is lined up to. Okay, so you want to be following the turtle's nose. The last little hint I'll give you, there is no exact right answer. Be as precise as you can. But just like in the warm-up, somebody was able to make a smooth line. If you all select this line tool, that will let you draw in straight lines as opposed to freehand. If you want to draw freehand, you can, but it's a little bit more difficult to be precise like that. And if you ever make a mistake, you can either clear it or use the eraser tool to erase parts of your line. So I'm going to give you all a few minutes here. Work on screens 7 and 8, and then 9 is a challenge screen. If you're done a little early, I'm going to leave 7 open, but know that I expect you all to get through 8. And when we pull back together, if you finished 8 already, work on slide 9, a bit of a fun challenge there for you. Okay, whoops. Slides 7, 8, and 9 available to you. I'll unpause and give you all a few minutes to work on that. I'm gonna actually pause you all here in just 1 second. So your screen should be paused. I'm gonna invite you back into the Teams call. I just want to highlight something that I saw super nifty and give you ideas for those of you who are having maybe a little bit of trouble getting started here. So please take a look at the Teams call. And I just want to show off 2 strategies that I see. So one student is using the line right away, and another student is using dots. And I'm wondering what this is maybe about, and just if anybody would mind unmuting and just letting us know if you're using dots or lines and what you think the different strategies are.
I'm using dots.
Okay, so Nina, can you talk more about that? Why did you decide dots?
So on the first video, I saw that the turtle moved, stopped, went back. So I was just trying to figure out, because you mentioned that the line shows the turtle's nose. And if you pause the video and you drag the bar, then there is a vertical line which shows you the time. So I'm just trying to find the turtle's nose at the different points so that then I can plot the graph.
Okay, so you're using the idea of critical moments. Like it looks like these dots are when the turtle is still stopped at those seconds. So you kept going and you didn't worry about the movement. You thought, I'll do it here and put ... because it's waiting.
Yes.
And then you just kind of found where it was at those. Okay, great. I like that strategy a lot, keeping yourself organized. Is there anything wrong with the line? I mean, this looks pretty good to me right now, right? In fact, when I hit play and start, maybe it's going a little faster. Did you all see that?
Yeah.
Okay, so maybe we're a little faster. So I invite you at this point, if you'd like, you make edits, do what you need to do. But I just wanted to show off those 2 methods since they're very different, but they should, and I see what you're saying, Sunina, eventually you'll make a straight line like this, and you'll connect your dots, yeah? Wonderful. Yes. I'm going to unpause, let you all continue. Pick the strategy that works for you. So while you all are working, again, exiting the teacher talk, right? Like that's a move that I made because if I had a class of 20 students, maybe I'd decide to let this go a little bit longer. I think I only let that go about 2 or 3 minutes. I didn't really kind of let you all play with it. And then I did this activity where I took Sunina's method. I thought that's what I want to do, is focus on critical moments. And I spoiled it, right? Like I spoiled it for the sake of our time, because I think it's good that students would try to use freehand or line tools. I would actually love to highlight a student that was using freehand, because that's going to be even harder to be accurate. But even with dots, and I did this actually not purposefully. So I'm going to invite you guys, I'm going to pause, and then I'm going to invite you to look at my screen. So remember, I told you the pro tip at the beginning, do it like a student, see what happens. I was trying to rush through it, and so I got it wrong on my first attempt. I wasn't paying attention to where I put the dots, so you can see that I'm up. But I'm going to show that off to students as an iteration. Like, look, my turtle went too fast. I paused in the right time interval, but at the wrong location. And then rather than ditching my whole graph, I just made new dots, and then I connected it by changing a different color. So like I can also reward like rough draft thinking if I want to. With it's okay that I got it wrong. I obviously got the general idea right. And at that moment, I think you can see from my screen that I'm using those critical points with dots, but I've used enough lines that maybe like neither one really works, but that might be something to highlight. Is I love that this went and found dots, and then we've connected those dots. You know, they were wrong at first, but I can see their thinking, because the goal for me is like a window into how a student thinks, right? And so that's also why I want to use classmate work to show off. Sunena, this is looking beautiful, right? I mean, this is amazing. You've plotted critical moments in the journey. I'm wondering what you're going to do here, and this would be fascinating to me. Like, I'm wondering, is this going to end up looking like this? Because I know that's not what happens in the video, but I'm wondering if you just kind of yourself knew that I'm going to just go all the way and then go, you know what I mean? And what's curious is if a student misrepresents, you'll see two turtles split right here, right? This should, well, now there's nothing, but this should start to generate at the end. A few there they were, a few turtles that showed up. So just something to think through, how you might present student work and reward it or not. Anyway, I'm gonna send you all to screen 10. I'm only gonna send you there just so you can see what a closing reflection might look like with this activity. So back to Desmos, screen 10, y'all been participating, we've been looking at different graphs, and so I have a slightly different challenge question. I'm wondering if you could read this graph to figure out the turtle's distance from the water at 3 seconds, and I want to know when you think the turtle is 4 feet from the water. And I invite you, use the sketch tool if it helps your thinking. If you're confident without it, that's all right. We'll chat about this one. Okay, I'll let you all know we have some disagreement here. So let's chat it up. Thank you for your thoughts. We'll pause and display what we've got our disagreement on. Let's see if we can settle a debate. All right. I got the two students here. Both said 6 feet for the first question. So let me just look at what that question was again as a reminder. What is the turtle's distance from the water at 3 seconds? So 3 seconds up to 6 feet. We had consensus on that as a class. But I'm wondering, who do we think is right here? 2 seconds, 5 seconds, 7 seconds, and 2 seconds for when is the turtle's distance from the water 4 feet? So right here, 2 seconds. I'm going to ask you to unmute and answer. Do we agree that the turtle is 4 feet away from the water at 2 seconds?
Yes.
Okay, so we agree. Awesome. How did they figure out 5 seconds though? The other student. Where do 5 seconds and 7 seconds come from? Take a look.
I think the turtle moved, stopped, then went back. So even at 5 seconds, because the turtle moved back, it was at 4 feet from the water. And then it walked further back and then again started moving forward. And so again at 7 seconds, it was at 4 feet from the water.
Awesome, Sunana, thank you. So you're seeing this turtle moving forward. So of course it got to 4 feet away from the water, but because it comes back again, it went back enough to get to 4 feet, and then it goes forward again. And I'm seeing that in this student's graph. Do you all see this with me? We've gone to 4 feet, and now if I draw a line all the way across, when am I 4 feet away from the water? It happens at these 3 moments, which are in fact 2 seconds, 5 seconds, and 7 seconds. So what I'm going to ask you all to think about here is, are we complete, right? I think we all agreed it is 2 seconds, but there are more times right? And so we need to be wondering, are we complete? So it's not enough just to hit the graph one time, it's every single time that we are 4 feet from the water. Awesome explanation, Sunena. Thank you for walking through that graph. That's what I've got for you all today. Hopefully your takeaway from today was you feel comfortable reading graphs. We're going to look more at turtles, at flags, at different things in life that move, and we're going to try to start to figure out what makes them a function or not. We're really going to explore this idea and what's possible and how can I look at a graph without a video to tell a story. So that's what's coming next time we get together. But for now, enjoy your day. Okay, I'm going to stop sharing my screen there and answer. Well, I can leave my screen shared for you all and answer some questions about what was the functionality that I was using and how did it, I'm going to ask you all, how did it feel to be a student in this? Was it more interactive than what you think online classes have been? Where are things I could have done? What are moves I could have done that were better? And it is hard with only 2 students, right? I mean, there's some of that. What do you think?
So I have a question.
Yes.
Even in a classroom setting, there are going to be students who finish at different points. So when you pause an activity and move them to the next screen, and you restrict them from going back to something that they have not completed, what is the idea that they go back and do it later, like at the end of class, later in the evening, or?
Sure. So I think there's a couple different philosophy things there. So I've left your screen paused. I've unpasted in case you want to look through the activity again later. So a couple ideas there, Sunena, and it's really kind of what your goals are. I would argue that the learning doesn't happen because a student completes it. It happens from the consolidation and conversations, right? So honestly, I don't need students to do every single screen themselves. Students really want that, but that's part of a culture you need to build up is making it explicit to students that I need you to interact with each screen so that talk about it. You're able to follow the conversation. I mean, just think about this Arnav's graph with the circle, right? We all 3 got it wrong. The gut instinct, and that is the gut instinct for all students, is to claim that the circle represents the physical path of the turtle, right? Not the rate. And frankly, I don't need a student to go back and correct their work. I don't even want them to correct their work because I just want them to realize that they had an iteration, they made a claim, that's awesome, and then we found out it was wrong, and that's okay. We were able to talk through how the elements of what we said were right. And then later on at the end, that's where I love that hopefully students are doing like what you did and figuring out I can read the graph for the 3 different times because this turtle is actually going forward, backward, forward, and that's where the learning is. So the other thing I'll say is in person, although this school year in person, it's recommended to put 2 kids on 1 device because then you're forcing that mini interaction anyway, so that I have to reconcile with you, my partner, why are you doing what you're doing on the screen, or do you agree? I'll type this in, and you have to encourage those mini conversations. And so not every student is going to finish it. Is I guess the long-winded answer I'm giving you is that's okay. But it needs to be explicit to students that they understand that that's okay.
Okay.
Mm-hmm. Yeah. What other ideas? I didn't even keep track when we start. I mean, I can see that this call has been going for about 45 minutes. Did that feel long to you all as students?
No.
Yeah.
No.
Okay.